Okay, so we are starting trigonometry. So we are going to do lots of algebra type stuff. And I think after you guys got used to it last year, you found out it actually isn't that bad. So we're going to start with right triangles. And this year, though, we're going to actually do trigonometry also in triangles that are not right. Well, today, before we get into the real trigonometry, we are going to do Pythagorean's theorem. So, let's say we have a right triangle. That is not a right triangle. So this is only going to work if you have a right triangle. Now, what is a right triangle?
A triangle that has a right angle in it?
Yeah, if it has a right angle, it is a right triangle. So this is only going to work for right triangles.
Is it possible for a triangle to have two right angles?
Not on a flat surface.
Okay.
Alright, so the longest side is the hypotenuse. In a right triangle, the hypotenuse is the longest side, and it is opposite the right angle. And what do I mean opposite? That means across from the right angle. So as we look at this, we can see here's our right angle, and here's our hypotenuse, and they are across from each other. They're not touching. The hypotenuse does not form the right angle. The other two sides then are the legs. So this is a leg, and this is a leg. And the legs are the shorter sides. There's two of them. And together they form the right angle. Together they form the right angle. So, all this to state, now we'll call this side side A. We'll call this side B. We'll call this side C, which gives us Pythagorean's theorem. A squared plus B squared equals C squared. In a right triangle, that is the case. So we can use this to find any of the missing sides in a right triangle, given that we have two of the other sides. I'll give you a moment to get all that down, and then we'll do a few example problems. This year, though, we are going to do one extra thing that we haven't done with Pythagorean's theorem in previous years. So we can actually use Pythagorean's theorem to tell if the triangle is acute or obtuse. Also, okay, let's go on. So let's say we have a right triangle, and let's say this side is 13. Let's say this side is 6, and this side is x. And I want to find the missing side. Now this is only going to work if I have a right triangle. So first thing, now, especially since we're going to be doing trigonometry, we're going to want to get used to identifying our sides. So this longest side that's opposite our right angle, that's our hypotenuse. We always want to know where our hypotenuse is first. There's our hypotenuse. That means this is the leg, and this is the leg. The common mistake is to use something that's the leg as the hypotenuse. Don't mix those up. Take a moment to figure out which is which. So we write our formula, a squared plus b squared equals c squared. We're going to replace in parentheses, a is 6.
Squared.
Okay, 6 squared plus, and b is x, and
Squared.
c is 13. Now we're going to follow the order of operations. We're going to go ahead and simplify that. So we get 36 plus x squared equals 169, and then we'll subtract the 36. We get x squared equals
133.
133.
Yep.
Ooh, now
And
it's the
then
square root.
we take the square root.
11.5.
Okay. And that is approximately 11.5 is what Jacob is saying. Now, your book is going to say this following phrase. Find it. Whoops. find it exactly. Okay? So if it says find it exactly, then this is your answer. But sometimes we get something that we can simplify here. So rather than me guessing through a bunch of things, I'm just going to put one up where we would need to simplify that root. Any questions on how we did this? Did you have a question, Coleman?
Yeah, for a Pythag, it doesn't actually have to be squared, does it?
Yes, it does.
Why is that? Because last chapter, I think when we were doing the triangles, proving if two sides added up to the longest side.
Right. That's just
basically the same thing.
to determine if the two sides, if we
If it was
had.
triangle or not.
Okay, so let's say if I have 5, 8, and then I'm like, okay, what's this side, right? And I'm asking, if this is a triangle, what is possible for this third side? Well, I could subtract those two, and I could get 3. And I could add those two and get 13, and then I see, well, then my third side is between those two. Another thing we did is we said, well, what if I had 8, 5, and say 10? And I was like, I asked, is this a triangle? And that's all I asked. Well, then we just took those two and we added them. We get 13 and we say, well, if those two add up to something bigger than the other side, then that. But that doesn't help me actually find out the other side. So we do need to square it. And the reason Pythagoras theorem, what Pythagoras theorem is saying, and you don't need to write this part down. What we're doing is we're saying the area of this square, if I put a square right here, and I find this area, and I take the area of this square, like I take this side and I copy it, and I take this side and I copy it, and I find the area of this square, and then I do the same thing with this. What Pythagoras theorem is saying is that if I take this area and add it to this area, I get this area. That's what Pythagoras theorem is saying. And you can easily prove that with Legos, or something like that. If you had triangular Legos, I guess. All right, anyways. Let's say we're doing Pythagoras theorem. And at the end, we get something like this. X equals square root of, let's say, 90. Okay, so we get that. And your book says, well, find this exactly. So we've done Pythagoras theorem, our x equals this, and we say, oh, we're done. We got it wrong because we need to simplify this radical. To simplify this radical, we take this 90 and we prime factorize it. So we do 9 times 10, and then 10 is 2 and 5, and then 9 is 3 times 3, and we write it in exponential form. So I have 3 times 3, that's 3 squared, times, now this 2 and 5, notice that they don't have anything extra, so we'll copy them down, but in the end we'll just put it as a 10 there. Now, I'm doing a square root, so what's the square root of 3 squared? 3. So the square root of 3 squared, and we did that by dividing by 2, is 3. So notice it came out, right? Because I did that square root. And the 2 and the 5, I can't do that square root. So this ends up being my final answer. Let's try one more. Exactly. Let's say I do square root of 98. So I prime factorize my 98. And 2 times 49. And the 2 will come down, and 49 is 7 and 7. So inside here, I write 2 times 7 squared, because I have 2 7s right here. Y'all with me?
Yes. Yes.
Okay. I can't do the square root of 2, but I can do the square root of the 7 squared. The square root of 7 squared is?
7.
7, and then root 2. So this is what your book is actually looking for, is this exact answer. Any questions?
Nope.
Give you a moment to get that down. And then we'll do another example here, Pythag. How you doing, Lane? Fine. Oh, let's all say hi to Kevin.
Hey, Kevin.
Hey, Kevin.
Hi, Kevin.
Where's Kevin?
Thank you.
Not here. With,
I'm like,
oh my goodness,
doing
Kevin.
something. So I think it's like for the whole week.
Hey, Kevin. Okay, here we go. Next example.
He's spiritually here.
Okay, we have
Nicholas.
maybe this is 7, and this is 4, and this is x. All right, so what do we write? How do we find this value?
We don't.
because this x is opposite to the right angle, so that's my hypotenuse. So that's my C. We're going to use C to represent the side opposite the right angle, the hypotenuse. So this is A, this is B. It doesn't matter the A and B. The one that's really important to get right is the hypotenuse. It's always opposite the right angle. So we get 49 plus 16 equals x squared. So we get 65, and then we take the square root of the 65. Okay, so this is our exact answer. That doesn't simplify, but we might try. We'll just get that. Those are both prime numbers, so root 65 is the final answer.
So we can just leave it as that. We don't have to give what the estimate is.
You have to read the directions, but I'm pretty sure many of the questions in your book ask for the exact. So that would be your answer. Sometimes this throws us off. So let's say I have 5 root 3. Let's say this one is root 2. And let's say this is x. Okay, so which one of those is the hypotenuse?
The 5 root 3.
Okay, this is the hypotenuse. That means the root 2 is a leg. And that means this x, that is also a leg. So don't get scared because you have roots in this. That's okay. So I'm going to write down my a squared plus b squared equals c squared. A is going to be this root 2, or the x, it doesn't matter. So root 2 squared plus x squared. And then c squared is 5 root 3 squared. Now, this is where you're going to have to, take off your helmet. A square undoes a root. Let me say that again. A square undoes a root. So this root goes away. And what do I have then?
4.
No. 2. The square, listen, undoes the root. So that means the root goes away, and so does the square, leaving me with 2. So I have x squared. Now, this right here is going to be harder. The square undoes the root, so that leaves me a what? A 3, but the square also applies to the 5.
So it's 10.
So I get
25.
So I get, what's 5 times 5, because it's 5 squared, that's 25, because 5 squared times, the square undoes the root, so times what? 3. So I get 75 right there, because 25 times 3.
Oh boy.
Now I'll subtract the 2, and then x is the square root of 73. Does anyone need to see another one that's similar to that one, where we have some roots in the mix?
Yeah, I'll let you know.
Okay.
I concur.
Let's get that one down. And then we have to, we're pretty much done at this point. We do need to do the one more thing, which is just going to be a memorizing. How are you doing over there? Feeling confident?
Yeah, man.
Good, we're feeling confident.
Are you?
Oh, absolutely. I'm confident that you guys can square and add things. Put them in the right order, perhaps not. All right, so let's say this is x. Let's say this is 3 root 2. And let's say this is root 5. Okay, so the x is the hypotenuse, which means these other things are the legs. So I write Pythagorean theorem. What do I put in for a?
Either 3 root 2 or root 5.
Okay.
I was about to say x, but then I remembered.
X is the hypotenuse, so x should go on the other side. And notice I put that into parentheses.
5.
So listen, yep, he's right. Square undoes the radical, so a square root and a square undo each other, so I get a 5 there. Plus, now this square applies to this and to this. It applies to both of those. So 3 squared is
9.
And then
4.
no, the square undoes the root, right? It goes away, leaving me with 2, not 4. Now, if you wanted to do what Justin is saying, let's just take a look at this. Like, we'll take this and put it over here. This literally means 3 root 2 times 3 root 2. What's 3 times 3?
9.
9. Now, what is 2 times 2? 4, but it's inside a root, right? And what's the square root of 4?
2.
So 9 times 2. I think you might better just remember that a square undoes the root.
Yeah, that seems easier.
Okay, then we have x squared. So we have 5 plus 18,
23.
23. And then we take the root and square root of 23. Okay, now since we talked about this square, I just want to make a point of this. If I had 4 plus 9, and I do want you to write this down because I don't want you to make this mistake. The following is a mistake. This is a mistake. Do not make this
Gotta write
mistake.
correctly.
So this is don't do this. Do not do this because it is wrong, and everyone falls for this trap. What we did up here is correct. This square applies to the 3 and the 2. This does not equal 4 squared plus 9 squared. I cannot distribute an exponent. It's non-distributive. That would be 16 plus 81, which is
A big number.
97. How do I know this is wrong? Well, order of operations says to do parentheses first. Can I add those numbers?
Yes.
Yes. And what is 13 squared?
169.
Notice these are not the same number. One of these is wrong, and this is the wrong part. Do not do that. You can't distribute an exponent. So why could I do it here? Because this is all multiplication. I can't do it here. Why? Because there's an addition. Okay, so that makes it different. All right, we are on to the last thing that we need to know for Pythagorean's theorem. Okay, this is important. So Pythagorean's theorem can be used to tell if 3 sides of a triangle make it acute, obtuse, or right. So we have 3 cases. Now here's our first case. Case 1. Case 1. A squared plus b squared equals c squared. Well, we've done that one. That makes it. If this is true, if this works, if this is true, then I conclude, therefore, it is right. It's a right triangle, if it works. Case 2. A squared plus b squared is less than c squared. So I add them and I get something that is smaller. Then I conclude, therefore, this is an obtuse triangle. Now this is something you're going to have to memorize. If I add up the squares of these 2 legs and I get something smaller than the hypotenuse, then it's obtuse because I'm saying these sides are too short and stubby to compare. So I get this. Okay? Obtuse. And case 3. I add up a squared plus b squared, and I get something that's bigger than c squared. Well, then I have a triangle like this, and therefore I conclude it is an acute triangle.
What's going on?
Okay, so we have 3 cases. I add them up, I add the 2 legs up, and I get the hypotenuse. That means it's a right triangle, if they're exactly the same. If I add them up and it's smaller, then it's an obtuse triangle. If I add them up and it's greater, then it's an acute triangle. So let's do 2 questions that ask this. I see some of you aren't quite done writing that. And then I think we'll have one more term, but really this is it that you need to know. And then we're going to do a bunch of practices. Are we good?
Yes.
Speak now. Forever be behind. Okay, here's our question. Determine if the triangle is acute, right, or obtuse. So I'll give you 3 sides. Okay? So example 1, here's 3 sides. Let's say I have 5, 12, and 13. Well, which is this? Now, I have to identify my hypotenuse. If this is a right triangle, which one of these is my hypotenuse? 13. That might be my hypotenuse. All right, so we'll say 5 squared plus 12 squared. And we're going to ask a question. Does that equal 13 squared? Well, 5 squared is 25, and 12 squared is 144, and 13 is 169. And when I add those, I get 169 is indeed equal to 169. So I say, therefore, it is what?
Right.
This is a right triangle. Now, last year when you tested this, if it didn't come out the same, you just say not right. Well, this year you have to say, well, is it acute or obtuse? So let's do one where it doesn't work out. Example 2. Let's say we have 3, 4, and 6. Okay, so we'll test it. This would be my hypotenuse. It's not always the last number, it's the largest side. So 3 squared plus 4 squared. And we're going to ask, well, does that equal 6 squared?
Well, no.
Well, this is 9 plus 16. Does that equal 36? Well, no. 25, 36. Now I need the right symbol here. 25 is smaller than, right?
Yes.
36, which means
Obtuse.
it is obtuse.
Oh.
Okay? You have to use this stuff. If it's smaller, it's obtuse.
Yes.
Any questions?
I said we have homework on this for tonight.
Yes, you did. Okay, last term. Pythagorean triple.
Triple?
I can barely do a single. Come on.
We've been doing, we did it.
count to 3.
Okay, listen. Pythagorean triple. There's a few ways to get a Pythagorean triple. I'm not concerned whether you know those ways or not, but a Pythagorean triple makes Pythag work. So it's essentially asking the same question that we just asked. Does a squared plus b squared equal c squared? So 3, 4, 5. My computer is having a conniption.
That's what I was saying earlier.
Okay, so 3, 4, 5. That is a Pythagorean triple. Why? Because
they're
when
in
I
order.
take 3 squared plus 4 squared, it equals 5 squared.
Sorry.
It works.
That
No,
was-
you're fine.
That was a real guess.
25 equals 25. It makes it work. A Pythagorean triple makes it work. So I would say, you would be asked, is that a Pythagorean triple? You test it, does it work? Yes. So therefore, yes, that's a Pythagorean triple. Right, so you just test the 3 numbers. All right, that's it. We're going to do a bunch of practices.